Hey guys, it's me, Simon, and welcome back to my channel. So I wanted to make another video because in about 2 weeks, so in most likely on the 9th of March, we will do the first stream for the platformer game development. And there was the poll where I asked what kind of thing we should use, so which engine, which language. And surprising for me was that actually Java was winning with libgdx. So because the people voted like this, you can see it here. We will then do, since you requested it, we will do some C++ programming with the Dark GDX game engine, which I used like 20 years ago when I started to learn developing in C++. And will be very interesting to see how this library developed and how we can use it then with our beloved C++ language. Of course, that's a joke, hahaha. So no, of course, we will use libgdx, but I'm not sure if we will use Java because for me personally, I don't like to use Java in my private project because I use Java every day at work since over 10 years now. I think it's almost 12 years. And while I think the language is great and you can do a lot of good things with it, I personally don't like it for my private projects because for me it's way too slow and sometimes the syntax is not as intuitive as I'd like it to be. I will elaborate on that point in a moment, so I will show you I will mention some examples why I prefer Kotlin over Java. And in the end, I'm honest with you, the project should be fun for me and I should have some learning going on and fun with the platformer development. And it's not for you. Of course, you can learn from it and you can watch me struggle and develop some things. But the main goal would be that I want to develop something and I want to have fun, which I think is then in the end more fun for you guys to watch it. So I will for sure use Kotlin and not Java. Although I thought about it because what would be very interesting for me is about the second poll where I asked which entity component system we should use. And most of you voted for the Flex entity component system, which is the Kotlin multi-platform entity component system. And therefore, it would be interesting how that looks like when you call it with Java. So we have different DSL stuff going on in Flex where you define the world, the systems, and so on. Most likely in Java, that will be setters, I could imagine. Maybe even you can pass there a list. I'm not sure. But would be interesting for me to see how that interacts with Java if we would use that entity component system. And also the second thing that I was wondering how Java developed. So for the project, my idea was to use Java 21, which I think is the latest version of Java, and see what kind of things have changed there. So from what I know, there are now record classes. I think even sealed classes or interfaces in Java. There's this pattern matching stuff with switch statements and instance of. There's also some destructuring, if I remember correctly. But in the end, it's for me always when Java introduces some features, it is still very verbose and not designed in a good way for me personally. So I prefer simply Kotlin over that. So that's why we will use Kotlin. Also, I asked here the community so why they prefer Java over Kotlin, and there were I think 2 or 3 people who contributed there in a little bit of a discussion. And the first one I liked a lot. So this guy here said that Java is actually verbose, yes, but with the auto-completion stuff and everything, maybe he uses Lombok. I don't know. You can get down to also very fast development and you don't need to write a lot. And Kotlin is cool, but almost too clever because the types get lost for the viewers. That one I want to elaborate a little bit on. And also the nested stuff inside the different brackets. And with the last point, I definitely agree. So even I tend to use a lot of nesting in Kotlin from time to time, especially when I don't have a lot of time to refactor the code. And I would say this is not really a problem with the language. That is more a problem with the programmer itself and using some bad practices. Because usually I would say when you are on the third nesting level, at that point, you might think about some refactoring stuff and simplify the code a little bit. I think in my tutorial series, maybe with user interface related stuff, I'm not sure. Maybe sometimes we are on the third, fourth, or even fifth level of nesting, and that is for sure bad. But again, that's not the problem with the language, in my opinion. That's the problem with the programmer. And usually you can simplify or beautify the code there and yeah, make it easier. And the second thing about the types which are getting lost, this is, in my opinion, a trend of more modern languages that you don't need to specify the type all the time because it's most of the time very obvious what kind of type you are getting. And I personally, um, I have the opinion that when you read a code, ideally you can read it like an English book. So I don't need to know all the types. So for example, when I assign a variable and I call a getter function to get something back, and then in the code below that I see on that object, for example, there's a method called which is set file, and then maybe an upload function, and reading all those methods in just these method names. With that, I get an understanding what that object is doing or what that variable is doing. And there is no benefit that I know it is file upload stream TO or file utility class or whatever. It doesn't matter what kind of type it is. I just know from the method that are getting called what its purpose is and what it's doing. And in my opinion, the type is not necessary and just adds a lot of noise to the code itself. The second thing is when you really have a problem in that specific code segment, then you anyway need to dig deeper into the code base there. You need to set some breakpoints. You maybe need to jump into the methods inside, check what's going wrong there. You need to analyze the stack trace and see where the error is happening. And at that point, also, in my opinion, the types or the name of the types do not really matter because you need to dig into the methods itself and find out what's going wrong. And it doesn't matter how it's called, where it's coming from. That is most likely not the problem then in the end when it comes to problems. So I know that especially the how is it called, dynamic types, that a lot of people out there, they don't like it a lot. But on the other side, there are also a lot of people which love them and prefer them. And I'm definitely one of the later group because, in my opinion, as mentioned before, most of the time, the type is not really important to know. It's more important that you have nice variable names, nice method names, and that the code that you are writing can be read like an English book. And that's, in my opinion, sufficient. The types are not that important. Okay, being said that, so we will start again the stream on the 9th of March, most likely. I try to stream every day in Central European time, evening time, so most likely between 7 and 8. And I will stream most likely an hour or 3 on the weekend, maybe even more. The reason is that I personally always need to work every day on these side projects because usually when I have a break for 2 or 3 days, then I tend to lose the interest of the project and then I just forget to work on it at all. So for me, it's very important that I work on it every day. If that's not possible, then at least every other day. So that's why starting on the 9th, we will have then streams most likely every day. And again, evening time, Central European time. Usually I will start between 7 in the evening and 8, something around that time. Okay, that would be it. So what I want to do now is to elaborate a little bit why I prefer Kotlin over Java, and I will do some side-to-side comparison in the IDE for those people which are not familiar with Kotlin yet. And I try to keep it short because actually yesterday I already recorded a video, but I forgot to record the screen. So I only had the audio without the video. So I need to do that again. And yesterday it was a 1 hour video. And today I try to keep it shorter, which is also not bad when you record a video the second time, then you can keep it shorter. So first of all, what I prefer in Kotlin is that you have built-in null safety. So there are special types in Java, for example, when you have a string, you define it like that, and you can assign something. And there's always the possibility in Java that you can assign null to an object, which then is, of course, a problem. So if we would do here then an if, for example, and call is blank, and then we want to do something, then that code piece here will throw a null pointer exception because the string is null, and you cannot call methods on a null object. And this null pointer exception, for everyone who worked in Java, it happens a lot. It almost happens everywhere. And it's hard to avoid because it's built into the language, and especially old libraries and old frameworks also return null values with certain functions, where nowadays people learned that it's better to return objects, so empty objects or blank objects instead of null. So for example, a very good example is if you have a method that returns a list or a set, then you should always return an empty collection if there is no content of the list instead of returning null. Because again, you can replace that string with a list and then just call here is empty or compare the size. And when you have an empty collection, everything will still work from your logic and won't throw a null pointer exception. While if you return a null list or null collection, then you always need to check, is it not null, and then do something, which is also not very nice. And in Kotlin, there are actually different types. So you can also have a string like that. We can also explicitly define the type here so that we say that here is a string. And when I have something like that, it's impossible for me to assign null, especially because I used here value. Let's use a variable. So it's impossible for me to assign null because I defined this here as a type string, which cannot be null. So already at compile time, I get the information if I would do something wrong or if something is null, which is great. And in Kotlin, if you really want to have nullable types, then you add this question mark at the end of the type, which then says, okay, it can be a string or null, which also has then the benefit. So like here, if I do the same thing, so we have the string and then there is blank method, the Kotlin compiler already tells me that is not a safe way to access this method because theoretically string can be null and you can use the safe access syntax, which is the question mark. So with the question mark, with the safe access operator, it either executes the isBlank method if string is not null, or it simply returns false here most likely if it is null, for example. So then it's simply not true, the statement, whatever you're writing here. And this is built into Kotlin, and especially in my private projects where I just have those 2D games, I have full control over the code base. So it's very nice for me to have the null safety built in at compile time. Also, just that you have heard it, the problem in my opinion, so this null safety is a good feature, but when it comes to interoperability with Java, there, in my opinion, it's not that great because in Java, when a method returns something, the Kotlin compiler simply doesn't know if it's a nullable type or not. And there they introduced a new type with the exclamation mark, like that, which simply means, hey, I'm not sure if the string can be null or not. So hence the exclamation mark, you need to take care of yourself. Could be null, but can also not be null. And at that point, so when you work together with Java libraries and you don't have control over them, at that point, in my opinion, this null safety functionality or feature in Kotlin is simply useless because you anyway need to check for null when you get types like that, because you cannot be sure that it's not null. So you have no benefits at all. But we are usually working just in our little game code base itself. So we have full control over the code base, and there we get built-in null safety, which in my opinion is a great feature in Kotlin. The second thing that I want to mention is the difference between in Java, when you call something and which can cause some problems, you usually always get the exception. So you have seen it most likely a lot of times. So you call something, then you catch an exception, and then you do something. And a good example would be, for example, you write to a file or you read from a file that usually throws then an IO exception. For example, if you cannot open the file or it's locked or doesn't exist or whatever. And then at some point, you also maybe need to close the file or delete it. So even in there could be a problem. So again, you need to add another exception block here and do something with it. And things like that, I find them super ugly. I don't like them. And also in most of the cases, let's say, those exceptions never occur. So I don't know, when I read a file and it's not there the first time I'm testing it. I just get this error that it's not there, and then I fix it and problem solved. And then I would say 99% of the time in the productive environment, it will also simply work, because why would the file get deleted, or why won't I be able to write to a certain file? Of course, there are always exceptions. That's why they are called like that. And there can be the case that something goes wrong, but usually what I see in most of the cases, there is no real recovery scenario. So most of the time what I see here, that some logging framework is logging the error here, and also the stack trace usually, and that's it. Then maybe it just throws a custom type of that exception, which the customer have overruled with a more specific one, and that's it. So basically the block here is basically useless, because it's just logging the exception, which I think is anyway happening if you would throw it. And there's also no real recovery scenario. Of course, again, there are exceptions, and I just recently had a case where I had to call another application, where I had to create some objects. So it was a SOAP interaction. So I had a SOAP service, and there I could create some objects over there in the system. And later on, I had some database statements on my own and some business logic, and there could be an exception. So something goes wrong at that point. And what I had to do then is that I call the SOAP service again, which is the other application where I don't have access to it. And there I call the delete object stuff to clean up the objects that I had to create there. And it was necessary to do it in that order. And here, of course, it makes sense. So if something goes wrong, of course, I want to clean up the objects that I created in that other application, because I don't want to have zombie objects. Of course, that call here again could fail. So the code was again more looking like that. And at this point, even if something goes wrong here, it was also just some logging of the exception and everything. But of course, cases like that make sense. But in my opinion, I personally think it's nicer if I don't get forced to catch every little thing that could go wrong in my code. And I prefer to just do real exception handling when I know I want to do something special and do something differently, and then just do it on my own when I know I want to do something. Again, this is more like a personal preference, but I'm just not a big fan of all these try-catch stuffs everywhere, especially when they are just some default stuff with logging. On Kotlin, on the other side, there are no catched exceptions, so I'm never forced to write a try-catch block. I can introduce it, so of course it exists there as well, but I don't have to. So even if a method throws an exception, the compiler won't complain that I need to catch it in some specific way, which I personally, as mentioned before, I prefer that. Good, then the next thing is a small topic. So in Kotlin, in my opinion, the immutability is better there. So usually they like that you have some mutable stuff. So for example, when I have a list and then I have a list of, for example, is some utility function, and let's make it integers, then this is a immutable list of integers, so I cannot modify it. If I really want to modify and have a mutable list, then I would need to use the mutable list of. There's another keyword, let's say, or another function for that. Also, it's very easy to make things like in Java, it's called the final stuff. So here in Kotlin, it's just the val, which means that I cannot reassign this list. So like here, I cannot assign another list to it or assign null to it or whatever, because of the val, which means I think value, I cannot reassign certain things. In Java, it's not so easy to do. I mean, it's not difficult, but it's not so nice to do. So here, let's make the same example. So I would have a list of integers. And here I have a new array list, for example. So here in Java, I can still assign everything to this list, for example, like null, which would be the worst case. And I can do things like that. To avoid that in Java, I would need to add this final keyword. Then I cannot reassign that variable. And it's then also not very nice to add this final keyword everywhere, because also in method arguments, which I think in Kotlin by default, if I have a method which takes an argument, the argument by default is final. In Java, everywhere I would need to add this final keyword, which I don't like a lot. Also, I think they added some new functions in Java lately. But most of the time, for example, when you work with streams, then at the beginning you had the to list, to set whatever, so you still got back your mutable collections. Nowadays, there's also to collectors like to unmodifiable list and things like that, so that it's more immutable. But still, in my opinion, in Kotlin, it's better and it's more the nature or built in into the language. While in Java, you always need to add this additional stuff. And yeah, I just prefer immutable objects and code because it makes it easier to understand, because you don't need to think about, does that get assigned somewhere else? I need to check it in maybe a very huge class. Where is that field getting reassigned, when in theory it's never getting reassigned, it's just assigned once in the constructor and that's it. And in Kotlin, in my opinion, that's very easy and clear to read. While in Java, if the final keyword is missing, then I always need to check, is there maybe something going wrong, or was the guy just too lazy to add the final keyword, which personally I am also too lazy, so I don't add final everywhere in my Java code. And yeah, so that's another reason for me to prefer Kotlin over Java. Another thing would be the functional programming stuff. So let's imagine I want to have a method, and there I take, for example, a string argument, and I want to execute a method which takes a string and it should return an integer, and that is the action that I want to execute on the string that I'm passing here. So what I can do then in Kotlin, I can call this action method, I pass the string, and let's also say this method is returning an integer. So I can simply return the action that I get passed in here and pass in the string. So in Kotlin, for me, it's very intuitive to write things like that. I think it's very similar in TypeScript, if I remember correctly. So I just have the brackets, which for the type of the variable, which indicates it's a lambda. So it's a function that gets called. Then inside the brackets, I define the types which are getting passed to that function. So it could also be another integer, another float, whatever, a custom object. So that one goes inside the brackets, and then I have the arrow and the return type, which gets returned. In Java, there, in my opinion, the functional programming, at least from what I know, maybe I just don't know everything there in Java, is not so intuitive. So there's the Java util function package, if I remember correctly. Let me check. Yeah, Java util function package. There you have a lot of different types for different lambda types that you can have. So a function, for example, is something that takes one argument of a specific type and returns something of a specific type. Then you have, I think, is it called provider or supplier? Yeah, then you have supplier, which is a function that just creates a specific type. Then you have a consumer, which is a function that consumes a specific type. Then all these interfaces have their own methods to call. So it's not just like writing a bracket and passing the stuff, which is, in my opinion, a natural behavior, because this is just how you normally call methods. Here it's more like you need to call then an apply method or a run method or whatever method. And in my opinion, this is just way more cumbersome and complicated than it needs to be. There's also the annotation in Java with the functional interface. If you know about that, then you can, from what I remember, define an interface with a single method. And the method in there defines then the type of lambda that you can pass. And then you can just use the functional interface name as an argument for your method. But again, in my opinion, this syntax here is way easier and for me also very intuitive to write than the Java functional stuff over there. I don't like that a lot. And what is then really crazy in Java, in my opinion, is a little bit the combination of that point and the previous point that I made. So when you have a list, let's make again a list of integers and make it a new array list. Then in Java, you have the, whoa, what did it do? What the fuck? Okay, I pressed something completely wrong. So in Java, you have the stream API, I think since Java 8. And there you can have some mapping, filtering, then the collectors and all of that stuff. And in here, I get here an integer, and then I can do something with it. And if I would write here some code that throws an exception, then in these mappers, again, I get this try-catch stuff, because I cannot simply throw the exception outside of the stream to the method. It needs to be handled inside all of that for me the Stream API, which is maybe related to functional programming. Then I see some people which are writing then their custom methods so that they can write all these Stream stuff without taking care of all the exceptions that can potentially happen somewhere. And yeah, in my opinion, this is just a combination of functional programming, and this exception enforcing is just a little bit annoying and ugly because, again, most of the time when you map something or filter something, it's simply a safe code. There is most likely never going something wrong, except maybe null pointer exceptions. But usually you find that out during the tests and then you just fix it or write the clean code from the beginning. So in my opinion, the combination here, I personally don't like that a lot, what Java is doing there or how you need to write down things. Then a quick point, I don't show here some examples to keep it shorter, is simply the standard library, which in Kotlin is really, really huge. So there are a lot of utility functions for collections, for strings, for whatever. And they are just built into the language, while in Java there is not a lot of built-in stuff. And also the functions which are available there are also dangerous because, again, as we have seen it before, there would be an isBlank function or the string, which is great. But as mentioned, the string could be null. So calling it like that can also throw a null pointer exception. So anyway, usually you have then for example, the Apache Commons language dependency or Commons collection or whatever. And then you have those, is it called str utils or string utils or string utilities? There are always different names for that. And there you would have then an isBlank, and there you pass in your string. So in Java, usually you have things like that. You have the utility classes because in Java, everything must be a class. And then you have the static utility methods. And what people then usually do is that you have then a static import somewhere over there for this method, which then gets rid of the string utils. So then in your code, you have at least something easy to read like that, which is null safe and also, in my opinion, good enough. But again, you need those additional dependencies or libraries. It's not built into the language. And in Kotlin, I simply get a huge amount of standard library features out of the box. I don't need to worry about searching some libraries which contain that. It's just built into the language, which is also very good. Okay, and finally, just I think that is one of the last points. Then I will stop it at that point. Are default values in methods, which I also love a lot in Kotlin. So let's imagine we have a method, we have a string argument, we have a number argument, which is an int, and we have maybe a Boolean argument. So we have 3 arguments, and then we do something in that method. So of course, I can call it in Kotlin with a string, a number, and a Boolean, which is very intuitive. But now imagine most of the time the Boolean is just false and people don't need to pass it. It's just some special thing that can happen in that method. So I can assign it a default value like this. So I can say by default, it's simply false if you don't specify it. So now I can call this method without the last argument, without the Boolean. So I simply skip it, and it's now the B value here will now always be false. And then maybe for the number as well, most of the time it should be 0 and you don't need to specify it. So we can just pass the string here. So it's as simple as that in Kotlin, that I assign just some default values, then I can skip it. In addition, I can make a combination here. So I can use the named arguments and make a call like this to make it even more clear. I can say here, the string is an empty string and the Boolean is true, but I'm skipping the number. So I can do things like that in Kotlin as well, which is also nice to make it short and simple. And that's it. So how would we do that in Java? So there we would have also a void method, which takes a string, which takes a number, and which also takes the Boolean B. So now we can call this method the same way. We also need to make it static here. So now we could call this method the same way, empty string, 0 and true. So that's how it works in Java. But what if we want to skip now the Boolean argument? So for that in Java, since we don't have default values for methods, we need to make another function where we skip the Boolean argument that is not needed. and then we just call the other function with our default argument. So we need a separate method here. Now, if we also want to skip the integer stuff, so if we want to call it like that, you already get the idea. We need to make different specifications for this method, override it again. So now we would need one method like this, where you also don't pass in the number. And then we could call the method now with string, 0 and false. And now that one here compiles as well. But what if we want to call now it with the string and just the Boolean, for example, like that? Again, we would need to specify another version of the method, which simply calls that version here. So you see it here, it gets quite big very easily with just 3 different arguments here and 2 default values. And in my opinion, it's just way faster, easier, and easier to read as well if you have default values like that, instead of having every possible combination of a method to avoid having some default values. So to have this possibility in Java. And this is also just a nice built-in feature into Kotlin, which I like a lot. And with that, I will skip it. So again, some of these points that I made are most likely subjective. So it's just my personal taste that I prefer. But some things, in my opinion, are really objective and better in the language. So you cannot really deny that. And that's the reason why I personally just like the Kotlin language and why we will use it for the upcoming project. Thanks for watching, guys. Have a great day and rest of the week, and bye-bye.